Hello everyone, I'm Eva Fifi and together with Afaliza, we will present about supercritical fluid extraction. Supercritical fluid extraction is a process that separates a component from another using supercritical fluid as the extracting solvent. We can categorize it under solvent extraction. A supercritical fluid is any substance that is at a temperature and pressure above its critical point. It can effuse through solids like a gas and dissolve materials like a liquid. For example, carbon dioxide. And carbon dioxide is commonly used in the food industry because it is cheap, inert, and non-toxic. This is a phase diagram for carbon dioxide. The y-axis shows the pressure, the x-axis shows the temperature, and the words labeled in red is the critical point. At a critical point, the vapor and liquid phase of a substance is indistinguishable. The area above the critical point is supercritical fluid. Let's move on to the application. SFE can be used to extract essential oil, extract flavors from natural resources, fat from food products, and also decaffeinating of coffee and tea. There are a lot of advantages in using SFE. First, it does not harm the environment. It allows selective extraction. It is a fast process, and last but not least, it can be simply separated from the analyte by releasing pressure. However, SFE is very expensive because it requires high pressure to operate, and carbon dioxide has limited dissolving power. Next is optimization. To maximize diffusion, we can increase the temperature, swell the matrix, or reduce particle size. Next, to maximize solubility, we can increase pressure and add low-level modifiers. Let's move on to the process.
Which is the process of supercritical carbon dioxide extraction. Process for the extraction. First, the raw material will be inserted into the extractor. The carbon dioxide tank is then filled with liquid carbon dioxide gas. The pump will then pump the liquid carbon dioxide into the extractor until the extractor fills up. The carbon dioxide liquid usually pumps below 5 degrees Celsius at a pressure about 50 bar. The carbon dioxide will then carry the oil particles that had been suspended into the PRV. It is then spirals down the cyclone separator as the density of carbon dioxide varies distinctly with pressure. Thus, the solubility of lower density of carbon dioxide is much lower and material will precipitate. The oil will then fall down as droplets in the collection vessel. Carbon dioxide, which is in gas form, then goes back to the carbon dioxide tank to be recycled. The pressure in the extractor is at least 74 bar, but mostly up to 350 bar depending on the raw material input. The extractor also must be equipped with heating element. However, in the cyclone separator, the pressure is lower than the extracting vessel. The process condition for this process is above the critical temperature and pressure of carbon dioxide, which is 74 bar and 31 degrees Celsius. Food. First, the quality of the flavor is nearly the same as the original flavor. Next, the microbial activity is reduced. And the third one, the increased shelf life as the inorganic solvent is eliminated. And last but not least, the temperature is not very high, thus the food quality is maintained. So that's all from us for today. Thank you for listening.